students, today's lesson is on exponents and scientific notation. So we'll start with a key idea, and that is that scientific notation is a way of writing a number as the product of a factor and a power of 10. That factor must be greater than or equal to 1 and less than 10. So let's look at some examples and see if they're written in scientific notation. Here we have 5.9 times 10 to the negative 6. So this is the factor, and this is the power of 10. 5.9 is greater than or equal to 1, and it is less than 10. So yes, this is written in scientific notation. If we need to explain that, we can say 1 is less than or equal to 5.9, and 5.9 is less than 10. Here we have another example, 0.9 times 10 to the 8th power. We have a factor, and we have a power of 10, but this time, the 0.9 is too small. So 0.9 is less than 1. We know that factor needs to be greater than or equal to 1. So this number is not written in scientific notation. So if we have numbers that are written in scientific notation, we can write them in standard form. And we're going to do that by looking at the absolute value of the exponent, and that will tell us how many places to move the decimal point. If the exponent is negative, we'll move the decimal point to the left. If the exponent is positive, we'll move the decimal point to the right. So let's look at some examples. Here we have a number in scientific notation, and we're going to write this in standard form. So we have 10 to the negative 4. The absolute value of negative 4 is 4, so we need to move the decimal 4 places. And in this case, because the exponent is negative, we're moving that decimal to the left. So I'm going to write just the digits 3 to 2. So I'm moving it to the left. So I moved it over 1 place already, and now I need to move it over 3 more places by adding 3 more zeros. And then whenever I have a small number, I want to put 1 more 0 in front of the decimal point. So I can kind of check this. I started with the decimal point here, and I moved it over 1, 2, 3, 4 places to the left. Here I have another number written in scientific notation, 7.9 times 10 to the 5th. So that 5 tells me I'm moving the decimal point 5 places, and because it's positive, I'm moving it to the right. So here I have 7, 9. So I've moved the decimal point 1 place already, and now I need to add 4 zeros to move it over 4 more places. So I have 790,000. And I can check that I started with the decimal point here and I moved it over 1, 2, 3, 4, 5 places to the right. Okay, so here I have just comparing some numbers in scientific notation. So an object with less density than water will float in water, and an object with greater density than water will sink in water. So use each given density to explain what will happen when you place a brick and an apple in water. So let's start by writing the density of water in standard form. 1.0 times 10 to the 3rd power. So I need to move the decimal point over 3 places. I moved it over 1 already, and now I need to add 2 more zeros. That's 1,000 kilograms per cubic meter. And then the brick is 1.84 times 10 to the 3rd power. So I can write 184. I've moved it over 2 places already. Add 1 0 to move it over the 3rd place. So this is denser than water, so you probably already knew that, but it will sink in water. The apple, on the other hand, is only 6.41 times 10 to the 2nd power kilograms per cubic meter. So that's 641 kilograms per cubic meter. So that apple should float. If you've ever bobbed for apples, you probably knew that too. All right, last we have an example about fleas on dogs. So a female flea consumes about 1.4 times 10 to the negative 5th liters of blood per day, which is not very much, but this dog has 100 female fleas on it. So we want to know how much blood all of these fleas combined consume per day. So we want to take this Amount of blood per day per flea, 1.4 times 10 to the negative fifth, and then multiply that by the 100 fleas. So let's start by writing this number in standard form. So I can, my 1 and my 4, I've moved it over one place to the left. Since this was written to the negative fifth power, I need to add 4 more zeros in front of that 1. And then I'm going to put my decimal point and put 1 more 0. So I started here, 1, 2, 3, 4, 5. And then I'm going to multiply that by 100. Now, we know that when we multiply by 100, that means we're moving that decimal point 2 places to the right. So now I'm moving it back 2 places here. So I have 0.0014, and that is liters per day. I could also write this as a milliliter. That might make more sense than leaving it as a liter per day. So a milliliter is 1,000 times as small as a liter. There's 1,000 milliliters in a liter. So I could multiply this by 1,000, move the decimal point 3 more places to the right. That's 1.4 milliliters per day. So it doesn't sound good, but that's not too much for our poor little doggy here. All right, go ahead and try a few on your own. I'll see you soon.